Hi everyone, I'm Aishi and I'm part of the INTERalliance Leadership Council and I'm helping to facilitate today's Tech Talk with Mark Gosson. INTERalliance's mission is to inspire and assist young talents to pursue an IT career in the Cincinnati area. If you'd like to apply to the Leadership Council that does all the work behind the scenes of this Tech Talk and other virtual events that we have, you can go ahead and go to interalliance.org and you can apply from there under the programs. If you have any questions, feel free to type them in the chat and Mark can answer them during his presentation and at the end. And just for a heads up, our other virtual events that are coming up, they're going to be starting July 10th and they'll be bi-weekly. Other than that, we also have a coding challenge, which is once a month, where we put out a prompt for you guys to code and we judge it according to how many lines you use as well as how efficient it is. And at the end of the month, we'll announce a winner, and the winner gets a $10 Chipotle gift card. So go ahead and check our Instagram and our other social medias to look at how to apply to those. Today, we're bringing in you Mark Gosson, who will be sharing his story and what he does at Microsoft. Thank you, everyone, for joining, and I'll let Mark take control from here.
Sure, thanks. So I'm in my current view, I don't see messages. So if someone pops one in, just holler so that I can switch over to it. But anyway, hey, thanks for just taking the time on what is otherwise a totally beautiful Saturday afternoon here in Cincinnati. So we're going to spend the next 45 minutes or so talking about cloud revolution. But since there's just a few of us on here, feel free to pop in with questions as we're going, because like there's really just there's plenty to talk about, and there's a lot of places we could take this conversation. So I'm interested to know kind of what your experiences are and what you're interested in asking about. But I'm what's known as a cloud solutions architect, which is kind of I don't know if that's the best title to describe what I do, but I work with very large customers, helping them plan their journey to cloud. So basically taking companies who are historically working in their own data centers, either on their premises or having rented space from somebody elsewhere, but generally moving them into a kind of a more cloud-focused, modern approach to their business. So the focus of this is really just going to be to help you understand kind of what cloud is, because it gets thrown around a lot. So it would be useful to just kind of, one, we'll define our terms a little bit and kind of give you a sense of what it means to be in the cloud, because it really is the kind of the fourth industrial revolution, as you're seeing there, and it's absolutely going to affect everything you do from here forward at least until the next revolution kicks in. But yeah, this was kind of a big one, and it's already affected all of our lives. Even before we got locked down by COVID, this was just a massive culture change across our industry, and it's been reflected in all of our lives. So I'll start with a question to see if anybody recognizes the person that I'm showing on the screen here, because he's probably touched all of your lives, but I don't know if you know who he is, so feel free to shout it out if you know it. Nobody? All right, well, his name is Zhang Yiming, and the reason he's affected your lives, well, I'm guessing he has, is the following. Okay, so does anybody not know what that's from now? Somebody feed it to me, come on, you guys use the heck out of it, right? TikTok. So yeah, he was actually the guy who started TikTok, and originally his plan was not at all to create a video sharing technology. It was actually to create an education platform, and he built out the platform, didn't get the reception and market that he was looking for in Asia, but he still had a little bit of venture capital left and decided to kind of pivot on it and turn it into a video sharing service. And we don't know exactly how much he sold it for, but we know he's worth in the millions, right? Probably in the high tens or low hundreds of millions. It was a quiet deal, but he made quite a bit of money, you know, moving very short videos around and providing that service out to the world. So I'll start with him, but we'll circle back to that conversation at the end. What I wanted to do though was let's just level set and talk about what it is when we're talking about cloud. So when I say cloud, I mean public cloud. There's also a term called private cloud, which we won't focus on terribly here because it's not all that widely in use, but it's basically companies that try to create very small versions of a public cloud. So anyway, let's look at what are the characteristics that really define a public cloud. So the first is you've got to have the ability to let your customers provision stuff for themselves, right? So if I want to stand up, you know, a Kubernetes cluster and deploy a bunch of microservices into it, I don't need to call, right? I'm not going to call Google. I'm not going to call Microsoft. I'm just going to go to a portal. I'm going to click some buttons. Stuff's going to happen, and then I'll have my code running out in the cloud somewhere. So that's kind of the first kind of key tenet to being able to call yourself a public cloud. The next is pooling resources. So what that means is there's an awful lot of compute running out in the cloud, and for reasons of practicality, they tend to be clumped together so that you can maybe disguise one, you know, server type as another. So we all the cloud providers will have relatively low cost SKUs, right? So servers that are relatively inexpensive, but generally speaking, the buildings that make up the actual data centers that are running cloud are not filled with cheap computers. They're filled with very expensive computers that are either pooled to appear to be lots of smaller, cheaper computers, or vice versa sometimes. Like some of the older hardware might get pulled together to look like more modern stuff. But generally speaking, there's a lot of stuff out there that we're trying to group together to make it appear as if there's the next tenant, which is a near unlimited scalability. So obviously in practical terms, that isn't really unlimited because there's physical space involved and hardware, but in terms of an average business's need to consume compute, network, and memory, it's practically unlimited, right? There's a very large number of compute out there, and we'll kind of give you a better sense of what that means down the road here. But the next is what we call pay-per-use pricing. So you don't need a contract to consume any of the compute that's up in cloud or any of the services that are out there. You can have, you know, large companies obviously do have contracts with us, but the way that you operate is you use stuff, and then at the end of the month you get a bill and you pay it. And that's, again, one of the key tenets of working in a cloud, because before the cloud, the way that you would do this is you would have to go and actually purchase all that hardware yourself, wait for it to arrive at your facility, you know, put it into a rack, power it up. You know, that's a very time-consuming process. And so just being able to kind of use it like any other utility, like you would pay for your internet or your light bill. Now, reliability is obviously critical, or nobody wants to use the product. So having a very robust and reliable both backbone and services that are out there is a core tenet of all these, right? No one's going to want to use something that they can't rely on for their business operations. And kind of the last category here is around the idea of not having to do maintenance yourselves. So again, when you were dealing with the previous world where you had computers on premise, you had to deal with their care and feeding, as it were. So make sure that they have power, they have cooling, that their networking is operational, patch the machines as necessary, you know, all that kind of stuff. So cloud takes a lot of that headache away from you, and let the cloud providers do that work on your behalf. And from there, you're kind of good to go. So anybody have a question with that? Just to kind of level set, when I talk about cloud, this is the world we're talking about, or these are the characteristics that'll help you pick it out from another. So if
you have any questions, you can put them in the chat, and then I can ask them to Mark, or you can just unmute yourself and then ask them.
Whichever. Yep. All right. Well, let me move on then a little.
We have a quick question from Vanya asks, can you explain resource pooling again?
Sure. So imagine, well, we'll talk about kind of the scale of actual compute out there, but being able to group like machine services together. So think about, something like a Kubernetes service where, there's I don't know if that's super familiar to you guys. How many of you are coding, but if I have a resource provider, right, that's providing a given compute resource to me, I want to be able to not worry about the underlying stuff that's involved. So whether that's attaching to one computer or 50 or 1,000 computers, I want to let the backbone provide that service for me. So pull those together and kind of treat them as a single unit to me. And likewise, like I was saying before, it's also being able to take really big compute and kind of slice it apart and present it as other things. So to kind of present whatever resources are being requested in a way that's largely invisible to the end user, right? That's the goal. So when you see the scale of it, it'll maybe make a little more sense as to how much there is and why that becomes a very important aspect of this. Okay, there's the chat window. Found it. Thanks. All right, let's move on a little bit. So if you wanted to start to build a cloud, like what kind of services would you think about building? So I'm going to show you the Azure product list, but this is, you will find a near parity across all the cloud providers in terms of these product categories, right? So what you see on the left are just categories of compute offerings. So AI and machine learning is certainly a very popular one, and then on the right there you can see there's cognitive services, there's Databricks, which is like an Apache Spark based implementation. There's cognitive services around search, around vision, around knowledge, and each of those have specialization. So what like cognitive services around vision provides is that someone's already built the ML models to figure out when you look at a particular image, like this is a cat or that's a dog, or this appears to be an ocean. Like that sort of stuff's already been built out so that you can go and just build your learning on top of that with much more speed, right? You don't have to go and cover the basics here. So you see there's also language APIs, speech APIs. So if you're doing evaluating input as text or just as a spoken word, all that work's kind of been done fundamentally for you, and it's just being surfaced as APIs. So it makes life a lot easier. There's also the bot service and just kind of general ML in there too. And obviously I don't want to walk through all of these, but just to kind of give you a sense of the scale and scope of what's out there, right? So here's all the analytics services around data factories, HD Insight, which is basically Hadoop, Synapse, which is a large elastic SQL clusters, right? There's just so much stuff that's going on. There's a whole blockchain category. The one that I'll spend some time talking about through the rest of this is around compute, because that's kind of where all the cloud, public cloud started, was around this notion of being able to spin up a virtual machine, right? Like I want to be able to have a virtual machine and install whatever the heck I want on it and then do stuff from there. So that's where all this began. And you can see now that Kubernetes is a super popular offering in there. Just running containers alone, if you don't want to have the overhead of Kubernetes, you can run your microservices that way. SQL, kind of scaling from there. So there's all kinds of stuff that you can do. And again, the idea is that the cloud's made some of the hard work easy for you so that you can just kind of get up and running quickly. Again, all kinds of container stuff, everything from Red Hat's OpenShift to container registries and function apps, things like that. Gobs and gobs of databases, everything under the sun. All these developer tools. So anyway, I don't want to belabor this too much, just to have an appreciation for when we say cloud, there's a lot of categories that cloud can take, and you see them there. And this is just across the industry, this is pretty common practice. So you'll see all these things out there. So let's kind of crack the hood open and look at what goes on in the cloud. So to start with, wanted to show a picture of a server. So this is a server that you might see, or one like it, in the cloud. And this particular form factor, the way it's configured is what's called a 1RU, and RU stands for rack unit. So they get stood up in these very tall racks, about as tall as a person, and they kind of slide into bays, and there's 42 of them that you can slide into one particular rack and go from there. So anybody here build computers for fun? I know some of you do around gaming in particular, but just curious if anybody's built one or knows what the inside of these look like before having seen this picture. No hardcore gamers. All right. Well, there's a couple things wrong with this particular picture that would prevent us from using it. The first one is you can see that there's in the middle of the screen there's these two empty socket bays. So that's where the CPUs would go. They're empty at the moment. So that would kind of limit the usability of this particular machine. But more importantly, in the front there, you can see that there's a couple of USB ports. Cloud servers do not have USB ports. They don't get managed that way. That would be a security problem for all of our customers if you had the ability to plug a device in there and actually, offload or download information. So, but anyway, as an illustration, this just gives you a sense of what one of those would look like. And normally speaking, computers of this type, each individual processor is made up of what they call multiple cores, little compute cores. So here you've got 2 physical processors, and normally they would have about 16 cores on average. So a machine like this is going to have 32 cores, which is an awful lot of, well, it's a good amount of compute. I mean, you've got maybe 8 cores on your phone at this point. So it's all relative, and we keep pushing these boundaries of technology as we go. But this is let's just start here for easy math. So this is what one computer looks like, and I've got 32 cores in it. And as I mentioned, they get put into racks. So you slide them into the rack, you hook up the network, the power, cooling, and all that good stuff. And then we just keep doing that until the rack is full, right? So we said that there were 42 RUs in a given rack. So let that fill out. Now, the racks get stacked into rows. So we put them next to each other, and to keep the math simple, I'll stop at 10 here. But if you're following along and you're quick with math, we had 32 cores and 42 RUs. So 32 times 42 gives us 1344. So each one of these racks has 1,300 cores in it. And if we've got 10 racks, then we know that we've got 13,400 cores in that row. Now, when we build a data center, we put the rows back to back for convenience, so that all the networking, plumbing kind of runs down that middle spine, power and all that. It just makes it easy to plug 2 machines in together because they're just back to back. So now we've gone from 13,000 to 26,000 because they're back to back. And this is what in the industry collectively is just called a row. And if you've ever seen a picture of a data center, they kind of look like this. They don't always have that fancy blue lighting in them, but whatever, it's a glamour shot. But basically, this is the idea. So you can see all the wiring going in there. You can see there's a lot of plumbing going on just above the computers. And if you can count quickly, you can see there's definitely more than 10 in that row. But we're keeping the math simple at 10. Also, there's some overhead, right? So not every computer in that row would be available to the end user who might want to consume its compute, right? There's going to be a management layer, so we've got to be able to provision out those machines, figure out who's on them, make sure that the correct identity controls are in place and that they have permissions to do things. We're also having to bill all that, so we've got to keep an eye on how long they're using them. So there's a lot of overhead. There's also networking overhead and storage going on. So we'll keep this down to 10 to keep the math simple, but just know that there's a whole lot going on there. So what the building that you saw there was what's known as a pod. And so the pods are going to consist of 24 rows, and that takes us to about 645,000 cores in a pod. Right, so now your 8 cores on your phone seems less impressive, right? Because we're starting to get into kind of big numbers here. So from there, let's jump out and have an actual look at an actual data center. So this is one in Virginia. that was being built out, and we got a picture of it that we're allowed to kind of share, which is good here. So you see at the very bottom, and I'll paint the little green box over it. That's a pod. So we've got 3, 4, 5, 6, 7, 8, 9 pods on that side. And then of course there's another side there, so that's 18, and then there's the back half. So that'll take us to 32. So this section now has, or 36, sorry. So 36 pods in this area gives us around 23 million cores. And now you're starting to get a sense that like cloud is really, really big, right? Now let's step back a little further. So the building that we were looking at is in the background there, and it's really small compared to some of the newer buildings that are being constructed. So if there were 23 million back in that back corner, just imagine, the hundreds of millions of cores that are out in a single data center, right? That's the power of like when we say near infinite scale. Obviously there is a limit, but it's an awfully big limit, and there's lots of companies that are going to be accessing that. So there's literally thousands of companies that'll be using that space. There are backups. So yeah, the question there is, are there backup cores in more rows, or the data centers designed for natural disaster? So yeah, the way that they're structured physically, you can see that they're kind of paired individually, and that's to protect against some of those problems. The real issue comes around natural disasters, right? So if this area were to flood or have a tornado or a hurricane hit it, there's another region that it pairs with that's usually within a relatively short distance, but far enough that it wouldn't be in the same floodplain. So short in terms of networking speed, since the network's going at the speed of light, you can get near instantaneously flipped over to another area that's not terribly far physically, but far enough that if something terrible happening in this spot, we'd still be okay. So yeah, it's a good question. Also, the way we ask that customers design things is that you think about having failures in the system. So it's less likely. Everybody jumps to the what happens if this whole region goes down, and I'll tell you that'll be a very bad day for whichever cloud provider that is, because there's hundreds of millions of compute that just suddenly got wiped out if that were to happen. But realistically, what happens is you have a piece of hardware that'll fail. And when that happens, you want to have your software written in a way that it senses that there's a problem and just fails over to another piece of hardware, generally in the same data center, but it could pop out to another region if that made sense. It would all kind of depend on the type of application. Another interesting thing to just think about in terms of failure with scale is, what would you think you would do if we were to go back to, let's see. Oh, yeah, that's the picture. What happens if one of the blades, one of the computes, one of the RUs in there dies? What do you think we do about it? And I think this is pretty standard across the industry, but I won't speak to anybody about Microsoft. So if we have a piece of hardware in there that goes bad, we do, well, no one answered, but you are correct. We do nothing. Generally speaking, because of the scale that we're working at, we would almost need 40% of the devices in a given rack to fail before we would send a person to touch it, because people cause trouble, right? Almost all the mistakes that you run across are caused by people making mistakes. So we go to great lengths to, one, have very few people that have access to these areas, and two, the scale that they operate at. If a few machines die, they just turn them off, and they take them out of the provisioning pools and move on. So the idea is to really limit the interaction with people and the problems that they will invariably cause. So yeah, the data, can the data be restored, is a great question. Yes, almost always. So I think all the cloud providers at this point by default will create 3 copies of any piece of data that you write. And you, as the consumer, can kind of decide whether you want those 3 copies spread out around this particular area of the data center, or the data center at large, or if you want them copied around the country or the globe even, right? We've got zone redundant storage that can be spread out all around different facilities or even further, if that makes sense. And when you talk about if you get into the space and you're interested about what happens when things go wrong, we basically measure uptime in the industry, what they call nines. Just how many nines of uptime are you looking to pay for? Because the more reliable things get, the more expensive they get. And generally speaking, you get 3 or 4 nines of uptime for most services is generally considered pretty safe. So that's 99.99% of the time it's available, right? Which means that it's not available 100% of the time, but the more nines it's available, the better that is. And something as simple as storage generally can have like 13 nines of availability because you have the ability to just spread that out across the region, and that's incredibly safe at that point. From there, though, the question gets like, how quickly can I restore it, which is maybe the better question, right? If my business is waiting on it. So there are strategies around that which are well beyond the scope of what we want to talk about here. But yeah, it's an interesting problem to have. And it's generally like, how much do you want to spend to have more nines and have the availability, nearly instantaneously recover. There are also just kind of better strategies around building applications now that are going to be resilient to loss, right? Like that's just a better design. I'll tell you an old joke that we have in the industry here around data centers. So the future of the data center, we used to say, is a one man and one dog. And the job of the man in the data center was to feed the dog, and the job of the dog was to keep the man from touching anything. Because as I said, people end up causing trouble. So we really try to limit their access to stuff, and when they do, there's generally speaking, you've got a situation where more than one person has to sign off on it, and they're super careful that they don't make mistakes. But if you follow the industry, you know that mistakes do happen. Patches get rolled out that take services down and things like that. So anyway, yeah, cloud is really, really, really big. And anyway, that was one region. So this is how many Microsoft regions are available currently. It was about 54 of them. So those dots aren't fully representative because inside the dots they're paired up again. But you can see that they're pretty well spread out across the world. Not a whole lot in Africa or South America at this point, but that's the general footprint. And that's just Microsoft, right? So the world's largest computing platform right now is Amazon's AWS Web Services. They don't have as many locations, but their locations are generally much bigger than ours, or historically have been. So you don't see as many green dots up there, but those are bigger spaces with more stuff in it generally. So you can see they kind of fall in the same area more or less as the green dots or the white dots. So before I click on the next item to show you even more dots, who do you think is the number 3 provider? So Amazon is number 1, Microsoft is number 2. Any ideas who the 3rd biggest cloud provider is? Google. That is an excellent guess, and you might be right. We're going to find out a little more as this year progresses. Intel makes chips. They don't make data centers at this point, but yeah, all those data centers that you see there are full of Intel chips. So that's a good guess. Anybody else want to guess who might challenge Google for number 3? I'll give you a hint. It's not an American company. So Alibaba and AliCloud there's a good chance they will outcompete Google for the number 3 spot this year because they really dominate in Asia. And historically, they're starting to branch out into the rest of the world now. Also, Baidu, I don't know if you know those guys. They another Asian company. They just said they were going to spend 1.9 billion in data center build out over the next couple of years, which, as you can see here, is small. 1 billion does not get you a lot of data center. These are all multi-billion-dollar commitments to building out as much compute as you see there. So anyway, that's kind of a footprint of the Google, Amazon, and Microsoft cloud. And that's not counting Google's search platform, right? The stuff that you would normally think that when you go to google.com, like that's nothing to do with these dots. These are separate services that they're selling. They may co-locate sometimes, but there's a whole nother set of compute behind that. And Facebook, of course, has its own massive set of infrastructure to go with all that. But again, they're not selling that as a service. So there's Ollie, just to give you the last piece of data in the puzzle. And you'll see Ollie's going to have a lot more data centers in China than anybody else. So that's why they're interesting to watch, because they're coming up quick from fourth place. Here's a picture that I tried to overlay of the world population. So the darker reds and oranges are the more densely populated areas. And you can see that there's an okay correlation in some places, but there's a lot of areas where people live that still don't have good access to cloud or kind of compute in general. So there's a lot more work to be done here, but this is where the state of the world today. So what are the different, sorry, the couple questions there. What are the different types of service cloud companies provide? So if you go back to the slides that I showed earlier, there were all those categories, right? So machine learning, data and analytics, general compute, there's all that kind of stuff, database. Those are the kinds of services that are being provided across all these clouds pretty uniformly. Is search server bigger than cloud size? Google doesn't disclose that. It certainly was for Google as they started to build out GCP. I don't know at this point whether or not they have a bigger footprint. They're rather tight-lipped about it. In fact, what you see here is kind of as much as anybody is willing to share around cloud. Cloud providers are very tight-lipped about their plans and kind of what's out there. And there's a few reasons for that. Part of it is just competitive, information. But the other is, like, if I was going to go and build a new data center in Chile, and I announced that to the world well before I've purchased the, as you can see, tens or hundreds of millions of cores of Intel and AMD computers that I need, it's very likely that one of my competitors would go into the region and try to buy up those cores as well. So, we have to kind of hedge our bets a little bit in terms of making sure that we've both got the facility ready and the compute secured from one of the people who make chips, because there's a whole lot of them in play there. Okay, so moving on. So as you can see, there was a whole heck of a lot of data centers out there, and they're using a lot of power. And so one of the things that Microsoft did earlier this year, back in the before times when we were all still allowed to go out in public, we made an announcement that neutral wasn't enough. So Microsoft's made a commitment to be carbon negative by 2030. So in 10 years, the idea is that Microsoft will be removing more carbon from the world that it puts in, and that the longer term goal by 2050 is for Microsoft to have actually removed every piece of carbon that we've put into the atmosphere since 1975, either directly or indirectly, right? So either by consumption of electricity or through our vendors. So that's kind of the commitment that we made earlier this year, which I think is fantastic. The other cloud providers have not yet made that commitment, but I'm not going to hold that against them. I'm sure by the time you guys enter the workforce and are productive, you will find that all of the cloud providers are going to be on the same platform, because this is just the direction the industry has to head. And here's just a little more information on the way that we're going to approach reducing that carbon footprint. So again, by 2050, the goal is to remove everything that we did since 1975 when we opened up. So clearly, most of that has been happening in the last 10 years or so when we started to build all those data centers. All right, let's see. All right, so we've been talking about cloud, but not all cloud is as cloudy as that. One of the things that the industry's playing around with, in Microsoft in particular, is around having data centers that are not those giant buildings that are taking up lots of real estate. And especially if you think back to that map where I was showing the world populations, you could see that, like, sub-Saharan Africa, for example, there's a lot of population there that isn't being serviced by cloud now. And it's kind of tough to, one, to secure the rights to, build those things out. There's national sovereignty issues. So some countries may not want you to build there, or if they do, they want to have control over it and not let the cloud be as accessible as it might be. So one of the things that we've been playing with is sinking our data centers into the ocean, which seems really weird at first. It's actually a pretty good idea from a computer's perspective, because You put it inside of one of those tubes, you fill the tube with nitrogen, and really all the bad stuff that would happen to a computer kind of goes away. There's nothing to oxidize because you're in a nitrogen environment. And what we can do is drop these on the coastlines very close to population centers. So the overwhelming majority of the world's population lives, I forget the stat now, but pretty close to an ocean, right? And so if that's the case, then we can bring these computing submarines and drop them in, and they can also be moved. So if if there was a need to have a lot more compute somewhere else for like the Olympics or something, you could just kind of haul them away and move them, which is an advantage that their brothers that are poured into concrete don't have. So how do large companies organize their cloud data, and does it overlap within racks and cores? So that's an excellent question, Natalia. So the way that they organize cloud data is generally inside of a data lake, right? That would be the traditional, well, traditional, but it's not like it's 20 years old, but yeah, a very large data lake. What'll happen though is that because of the tendencies of cloud that you saw in the beginning, like resource pooling, they won't know where inside the data center any of their stuff is. So when you pick to either deploy computer storage or whatever into the cloud, you pick the region, but that's kind of it. So it's not like you get a map with all those pods in it and you say, I want to put stuff in this pod and in that rack. It doesn't work that way. We handle all that stuff for you. And frankly, it could move, like potentially if it seems like there's failures happening there with lots of hardware, we might start to just migrate data across to other areas, again, invisibly to the end user. But yeah, so they're not actually tracking where stuff is, although they might in a traditional data center, if they owned it, they might know that the HR data is out on that particular server or in this particular rack. But yeah, they just kind of let it go out into a giant pool, and it gets abstracted away. So one of the beautiful things about technology as it moves forward is that abstraction continues to happen. And by abstraction, I mean just taking the interesting stuff and making it less interesting, right? Like if you're a tech nerd, it makes it a lot less fun. But like in the old days, you would build a computer yourself, and then you would install software on it. And now you might have a computer that you run a hypervisor on, right? So instead of building out a bunch of individual machines that only run one operating system, you can have a single operating system that's abstracting out the hardware to virtual machines, and then virtual machines can abstract out their hardware and information to something like a container, and then you'll even get things like functions which are abstracting even further out. So as time goes on, you're going to find that the industry is moving further and further away from the hard bits of the bits and bytes, the pieces that are out there, and it'll just be kind of these abstract concepts. Are Microsoft's clients usually smaller companies or larger companies? They span the gamut, really. The really cool companies are out in Silicon Valley, tend to be on Amazon. They were, they were earlier and they were more popular with, the Ubers and, all those kind of companies that were kind of built into the cloud. So Microsoft's kind of core business, I think we'll find, are traditional enterprises that have been around for a little while. So whether they're mom and pop shops or, something as big as like, a Kroger or General Electric or whatever, they span that gamut, but they're all across the board. They're just generally not brand new companies. That's what I mean. We'll fight for them, but a lot of times the cool kids pick Silicon Valley and and don't think up to Redmond, but that's okay. Is there a limit to how many virtual machines can be on an operating system, or does that depend on the computer core count? There is a limit, and it kind of depends on how many cores you have. And it'll depend on the hypervisor that you choose as well. So yeah, I mean, practically speaking, you can slice out those cores and share them pretty effectively, and you can do something that's called over provisioning, which airlines do or used to do when they had a lot of people trying to get on the planes, is they would like sell more seats than they actually had because they realized that some people weren't going to make their flights and just weren't going to show up. So a hypervisor can do that as well because they realize, or generally the people that are building it realize that, hey, I've got 100 systems that I can run on here, but at any given time, there's only like 40 that are really busy, and the others are very quiet. And so if they were all wake up at the same time, it would probably overload the system. but we know that that doesn't generally happen. So we're going to over provision and put more stuff than can reasonably happen if everybody was using it at the same time, but they're sharing in a way that is pretty effective. So anyway, good questions. So a couple other things I just wanted to talk about were just the opportunities that are coming. So if you look at things like artificial intelligence and look at the value creation relative to gross domestic product and the growth of AI, you can see that the United States and some of the Scandinavian countries are doing really well there. And you know, this is definitely an area of focus, especially if it interests you as a career. Like artificial intelligence is going, and machine learning have an awful lot of room to grow over the next decades. It's definitely a super interesting area, and it will pay very well, I'm sure. It already does, honestly. If you have big data skills, they're very commoditizable right now. But on the other hand, like it's definitely causing societal impact, right? One of them is that it's displacing jobs, right? Hopefully, you didn't want to be a loan officer or a paralegal or a retail salesperson, because the odds of those jobs being automated are incredibly high because they're very easy to automate, right? They're very predictable. We all know that you probably don't want to be a taxi driver or a chauffeur in the long run, and not just because you can do it as a side hustle, but because everybody's working on autonomous cars, and once that happens, why would we expect that there would be more taxi drivers? So anyway, you can see the list there. The good news is if you want to be a lawyer, you're probably safe, or a musician or a singer. It'll be a while before the computers take over those jobs from you. So that's some good and happy news there. The other thing I wanted to just kind of show is the opportunities that are out there. I missed a slide, sorry. I wanted to show this as well. So the gray half of the slide here is what I want to point out. So this is the number of folks on the planet that have access to internet. So basically what this graph tells us is that in 2016, which we can track that a little further, but we had 46% of the Earth's population that had internet access. That's not that good, right? Maybe it's 50% now, but there's still a long way to go before everybody has access to cloud. And you saw that just translated from where the data centers are being landed today. There's a lot of opportunity in India, in South America, as well as Africa to really increase the penetration of internet and by that the virtue of the opportunities that it brings. So here's kind of the good news, right? If you look back at the last 100 years or so, we've done as a planet, we've done an outstanding job of lifting people out of poverty. Where 100 years ago we had 94% of the population living in poverty and 84% living in extreme poverty. And now we're down to where that's just 10% living in extreme poverty and 36% living in poverty. So that's a really awesome trend. Like, that's what we want to see continue. And cloud's going to give us the tools that we can do to really, once we reach those people, we can really increase their standards of living and make their lives a lot better. The bad news here is that 10% is still 780 million people, right? That's 10% doesn't seem like a lot in the 100% scale, but in terms of real numbers, that is a lot of folks. And that 36% represents 2.8 billion people, right? So there's definitely work to do, but it's encouraging to see that technology is helping push this down, especially like since the 2000s, right? Like that's a nice dramatic drop that you see from 2000 to 2010. So that's all great news. So the last thing I wanted to kind of share with you is we started the conversation with the fellow that invented TikTok, but I want to introduce you to a person that I met when I was in China. I spent some time there working for Microsoft, and this is Mr. Chang, and he ended up being my barber. And as you can tell, this was not hard work, but when you're in China for a long time, you eventually do need a haircut, just like during the COVID lockdown. So he operates out of what's just a street barber. This is a super common practice in China. And the reason that he's able to do this is the cloud ultimately, and in particular, some decisions that the Chinese government have made around how they're operating. But what he's well, the reason he's a barber at this point was because in the late 90s, China started to take down a process that they had called the Iron Rice Bowl, which was basically a social safety net. It meant that you had a job for life. And when the factory that he worked in closed, he ended up having to look for other work, and he was able to find work as a barber for himself. So he basically has a chair, he's got some scissors, and in this case, you can go real fancy and even have a mirror and a little broom. But the only other thing he really needs to pull this off is a phone, right? And that's where like WeChat comes in. So if you've ever used WeChat, you might understand, but it's incredibly interesting how WeChat has impacted China in particular, but Asia generally, because everything from going into a restaurant and ordering your food to paying your bills is all done through a single platform, which really kind of dwarfs the things that Facebook can do. But yeah, all he does is you present a barcode on your screen, he scans it, and you've made a payment for his haircut. So he didn't need any kind of infrastructure to do that. And that's really the opportunity that I think that cloud has, is to take technology like WeChat and to enable people to just be able to create new opportunities for themselves, and to be able to earn a living in a way that maybe wasn't possible or was much more complicated a decade or so before that. So I know we're up against the time. I can talk on and on about this topic, so I appreciate all the time and attention. And I guess we can stop there, but if you've got other questions, let me, I think that's the last question I saw pop in, but feel free to chime in if you have others.
Feel free to unmute yourselves too if you have any questions. Otherwise, I'd like to thank Mark. Thank you so much for this very interesting and informative session. For everyone participating, thank you for joining and asking really good questions. Otherwise, keep in touch with all the events that we have upcoming. And if you want to join ILC, go ahead and go to the website, interalliance.org, and under the Programs tab, join ILC. If you have any other questions right now, feel free to put them in the chat or unmute yourself. Otherwise, thank you, Mark. This was a very, we have a question.
Awesome.
From Natalia, and she says, are there ways to make your own cloud to practice?
Yeah, so, well, you saw how big they are, so you don't want to build your own, but there's definitely ways to practice. So all of the cloud providers offer basically like a limited trial. So you can either sign up and kind of play with, I forget what the dollar value, it'll probably vary by provider, but they'll give you a credit that you can play with for a while. Also, like in the Microsoft world, there's the Microsoft Developer Network, MSDN. So if you're part of that, you have access to the cloud, and you get a certain number of credits every month that you can spin up stuff and play against. There's also, I'm trying to think of the other ways. I think you can also go online. So Microsoft Learn is a great resource. You can go out there and you can practice some things there. You can't do super fancy stuff, but some basic stuff you can certainly spin up there. And yeah, I would encourage you to see if your schools have any partnerships with any of the providers. I know I think INTERalliance is going to be working with some teachers for next year, and I'll be teaching a longer course to them on kind of how to do this. So as part of that, those courses will obviously have access to the cloud too. So yeah, so ask around is probably the best bet.
That sounds good.
Okay,
and then we have another question from Lee. What company do you think has used cloud computing the best or in the most innovative way?
Oh, that's a very good question. I mean, Google's certainly a contender there. It would be hard to argue that their search algorithms were not innovative. It may not seem so these days, but at the time, they certainly were. And they basically built Hadoop, and the idea, the modern idea of big data is all kind of coming from that. So that was super interesting. I think there's a lot of stuff that is coming out around, Facebook's done some innovative things. I don't necessarily think that they're all for the best, but the way that people are being commoditized and what's called data exhaust. So all the data that you produce is termed an exhaust at some point, and the insights that they're able to gain from that are certainly innovative, as long as they remain ethical. That's I think the key thing. But yeah, there's a lot of stuff that's happening kind of across the industry. Obviously, Microsoft does tons of stuff. I don't want to short sell us, but I was just trying to be respectful of the other cloud providers too. Yeah, I mean, Microsoft is kind of treating data privacy as a human right. So we've got a lot of interesting and innovative stuff that we've done just around kind of democratizing data and AI. So as I was mentioning earlier, like not having to go and figure out how to detect a dog or a cat, right? Being able to just use a library that already exists, that makes that democratization quicker, so that people don't have to have PhDs in machine learning to be able to execute things. Are there any other countries that are upping their cloud capabilities? That is a good question. At the world level, I don't know if I know of any, because most of the cloud providers have built out across Europe. So the individual countries themselves don't have to make as large of a contribution. That's a very interesting question. I'm sure some of them are from a country perspective, but not necessarily from a commercial perspective, right? So building it out for their own benefit, I'm sure that's going on. But yeah, in terms of seeing companies that are kind of tied to their national identity, I don't see a whole lot of at this point. Although it wouldn't surprise me that might change. It's just the amount of investment that is required to build these are, like I said, are multi-billion. So it's definitely something that you'd have to have a good-sized country with a little bit of a spare capital to make that work. But yeah, interesting question.
If those are all our questions, I'd like to thank everyone for joining, and thank you, Mark, for having this session.
Sure.
It's really good having you.
Thanks. I enjoyed it.
Perfect. Thank you.
Thank you, Mark.